Welcome back to my YouTube channel. Today we are going to be looking at kinetic energy and how you can get the formula for changing kinetic energy from work done. Okay, so we all know that work done is equals to force by distance, and in this video I want to represent distance with S instead of the usual D. So our work done will be equals to force by equals to Fs. Okay, so from our previous knowledge on change in momentum, we know that we have the mass by the velocity, final velocity, minus the mass by the initial velocity equals to Ft, which is force times time, which is also known as the impulse. Okay, so we are going to make force the subject in this equation. We have mv minus mv naught out of t, and then we are going to substitute this equation 2 into our equation 1. So we have here, so w is equals to, we're replacing our f with this, which is the mv naught, the mv minus the mv naught out of t by s. So we have this. We are also going to be using our Stewart equations to be able to solve this. So from our Stewart equations, we know that v squared is equals to v naught squared plus 2as, right? And we are going to make s the subject in this formula. So s will then be equals to v squared minus v naught squared all out of 2a. And with this, we can substitute our s into our s up here. So work done is equals to mv minus mv naught out of t by this s here, which is v squared minus v naught squared out of 2a. Okay, so with this, what we are going to do is we're going to multiply through and factor out. So w will be equals to mv minus mv naught by v squared minus v naught squared all out of 2at. Okay, so let me rewrite that up here. mv minus mv naught v squared minus v naught squared all out of 2at. Okay, so we have this here, and we can further factor out. So m would be equals, in m into bracket, v minus v naught multiplied by v squared minus v naught squared all out of 2at. Okay, so going back to our Stewart equations, we have v equals to v naught plus at. We're going to make at the subject here. So we have at, which is equals to v minus v naught over here. And if you look at our equation for work done here, we can see at here. So we can substitute this at into the equation. So w m v minus v naught v squared minus v naught squared all over 2 into bracket the formula for 80 we got here, v minus v naught. And you can clearly see that we have v minus v naught up here for the numerator, and we also have it in the denominator. So we are going to just cancel those out, and what we have is our work done being equals to m into v squared minus v naught squared all out of 2. Okay, so we can multiply this through to get mv squared minus mv naught squared all out of 2. And from our previous knowledge, we know that the formula for kinetic energy is half mv squared. But what we are looking for is the change in kinetic energy. So change in kinetic energy would be half mv squared minus half mv naught squared. Okay, so this is essentially the same as this, which I will show by just separating the equation. So you are going to have half mv squared minus half mv naught squared. Okay, so that is, there you have it. So I've been able to prove that you can actually get the equation for change in kinetic energy from the equation in work done. Thank you so much for joining me today. Bye.